Hello and welcome to this lesson on the displacement reactions of halogens. In today's lesson, we will recognize that a more reactive halogen can displace a less reactive halogen from an aqueous solution of its salt. Then we will learn the color observations for each halogen displacement reaction. So far, we've discussed the halogens, elements found in group 7 of the periodic table, and you've become familiar with their properties and reactivities. You should be familiar with the trend in reactivity down the group, that halogens get less reactive as we move from fluorine to iodine. Building on this foundation, today's lesson will advance our chemical understanding by exploring how reactivity differences among halogens lead to displacement reactions. A displacement reaction occurs when a more reactive element replaces a less reactive element in a compound. Specifically, in the context of halogens, this involves one halogen displacing a halide in a salt solution. Let's start by defining a halide. Halogens, like chlorine, Cl2, bromine, Br2, and iodine, I2, can exist in aqueous solutions as halide ions. A halide ion is a halogen atom bearing a negative charge. For example, chloride ions, bromide ions, and iodide ions are common. These halide ions come from salts such as sodium chloride, NaCl, or potassium bromide, KBr, when they dissolve in water. A more reactive halogen can displace a less reactive halogen from its aqueous salt solution. For instance, consider chlorine, Cl2, which is more reactive than both bromine, Br2, and iodine, I2. If aqueous chlorine is added to an aqueous solution of potassium bromide, KBr, it will displace the bromion. Cl2 aqueous plus 2K bar aqueous produces Br2 aqueous plus 2K Cl aqueous. In this reaction, chlorine displaces bromine, forming aqueous bromion, Br2, and potassium chloride, KCl. During a halogen displacement reaction, you can often observe a color change. For example, chlorine, Cl2, in solution is pale green. Bromine, Br2, in solution is orange. Iodine, I2, in solution is brown. When chlorine displaces bromine from potassium bromide, the solution turns from colourless, or very pale green if chlorine is in excess, to orange due to the formation of bromine. Similarly, if chlorine displaces iodine from potassium iodide, the solution will change from colourless to brown. The following table summarizes the color changes. Note that you do not necessarily need potassium salt specifically, since potassium is not involved in the reaction. Sodium or any other metal that forms a salt with halogens also works. By understanding these displacement reactions and observing the associated color changes, you can identify and predict the reactivity trends of halogens. The reactions show us that chlorine can displace both bromide and iodide, meaning that it is more reactive than the two of them. We also find that bromine can displace iodide, telling us that bromine is more reactive than iodine. Finally, iodine does not displace any of the halides, so it is the least reactive out of the three. This confirms our theoretical trend in reactivity, which should decrease down the group. In today's lesson, we looked at reactions involving halogens, noting that a more reactive halogen can displace a less reactive halogen from its aqueous salt solution, with reactivity decreasing down group 7 of the periodic table. For example, chlorine, being more reactive than bromine, can displace bromine from potassium bromide, forming bromine and potassium chloride. This principle is rooted in the relative reactivity of halogens, where halide ions like chloride, bromide, and iodide form when their respective halogens dissolve in water. Our lesson also looked at the color changes during a halogen displacement reaction, which inform us of the energy changes that occur. Chlorine in solution is pale green, bromine is orange, and iodine is brown. When chlorine displaces bromine from potassium bromide, the solution turns from colorless, or pale green if excess chlorine is present, to orange. Similarly, when chlorine displaces iodine from potassium iodide, the solution changes from colorless to brown. Good work! See you in our next lesson as we will continue exploring the halogens.